George Symons, for those of you who I haven't met, CEO of Gridstore. And we'll spend a little bit of time right now with me before we get into the real meat of the matter. A little background on the company. What I'll do is give you the high-level positioning of the product, and then I'm going to turn it over to Kelly Murphy, founder, CTO, who will go much deeper into the product strategy. And then we have a tag team with Shri and Don, who will go further yet into product details for you. So we'll cover this in a few different sessions as we go forward. As far as the background, Gridstore was founded in 2009. We did a Series A funding in 2012, mid-year. We had an initial product to prove out the technology based on some file serving. And then in July of this year, came out with beta with our current block product. We went for we went for early access in mid-September. Really pleased. We had 8 good end-user beta sites. All 8 actually converted to paying customers in that September timeframe. We did the GA of the product in November 1st. The real purpose was to coincide with R2 from Microsoft. Didn't make sense to do a GA, have R2 come out, and have to do another release right after. So we did a GA of the product November 1st, supporting the latest release from Microsoft. And we're seeing now multiple repeat orders from customers. So very good signs as we continue to go forward. As I mentioned, I've been around storage too long, too many places, and not worth going into that. Kelly, as I mentioned, founder, CTO. We have a really solid team. I brought on John Ferraro, who I've known since my days at Legato. He ran InMage for a while, has come on to run sales for us. Mark Herbert, who you may or may not meet as we go through today, depending what questions you get into, is our VP of Engineering. Mark came from Drobo, and that sort of ties to Jeff Barrell, who you also might run across this afternoon if he gets here. He's the chairman of the board and person who brought me into the company. So, talked about the beta sites, having 8 of them. We're very much targeted at that mid-market. Now, what's the mid-market, right? So for us, the mid-market is roughly a $100 million company to $2 billion. You can do it by number of employees, all sorts of ways to measure it, but that number sort of works. And we're very much targeting customers who are HyperV and Windows Server 2012, 2008 as well. But really targeting that HyperV market, as Microsoft has done a great job in penetrating the mid-market with HyperV. So the alignment with us works very well. It is a horizontal solution, but we are finding good traction with a number of verticals. Higher education, oil and gas, manufacturing, technology. We actually have 2 service providers as part of our early customers, so we're seeing that traction as well. So wide variety of sort of who you would expect, and even a few who you wouldn't expect in that category. Now, what are we? Who are we? We fall into the category of software-defined storage. I'll tell you, for a while, I didn't want to say that because it means nothing, or it means everything, or some combination of the above.
What you want it to mean.
Exactly. So it is software, right? Software is anything. But it is the right definition for us. So we said, okay, we'll go with it. So we fall in the category of software-defined storage. The goal here is that we dynamically accelerate application performance. Being software, sitting as we do, and we'll talk about it on the server side of it, the application server side of it, we can do some intelligent things to help applications run better. Also, because of the way we integrate into the environment, we're very simple to manage, and to manage from a virtual machine level, not a LUN level. So as you look to do a snapshot, you're not doing a LUN snapshot, you're doing a virtual machine snapshot, for example. As you look at it from an admin's point of view, it actually looks like a local device to you. So you manage it the way you would a local device. A lot of advantages for that configuration. And putting all this together, as you'll see, gives us a real good position in the marketplace with the combination of price performance, right? We're not cheap storage. We're not $1 million IOPS in a small configuration, but getting the right performance at a good price with a couple of different ways of doing it, which we'll talk about as we go forward. So for many of you, this may be 101, or you could come up here and do this part of the presentation, but the whole idea, virtualization breaks storage. Well proven in many different ways. We have the I/O blender effect. You have a single LUN sitting out at the end of a wire, presenting it to many different virtual machines. None of that is well set up for a virtual environment. And we surveyed our customers. I've seen surveys that other analysts have done. It all comes back with about the same thing. The biggest problem is application performance. When I virtualize an application, my customers, my end users aren't happy about it. There's a performance problem. Now, some people have solved that performance problem. You over-provision, right? Over-provision capacity, over-provision performance. You solve your performance problem, and now you've got a cost problem. So that was number 2 on the list, was it costs too much. And then the last one we heard was just the complexity in those environments of trying to manage storage. And part of that reason is it's not the storage admin necessarily anymore. You have the virtualization admin who isn't a storage expert. And so, those are the real things we looked at as we put the solution together, is solving those problems. So what is the solution, right? What we've done is focused on both physical and virtual servers, because there is no such thing that I found as a 100% virtualized environment. And in that environment, we load a virtual controller, right? We call it our patented server-side virtual controller technology. It sort of rolls right off your tongue. We put a virtual controller on each of the physical and virtual servers. It fits in at a driver level in the Windows environment. So very easy to install, no downtime to install it. But what that virtual controller does is it allows us to optimize the IOs coming from each virtual machine. And when we say optimize the I/O, 2 things. One is, yes, we clean up the I/O blender effect so that we put things into queues. But as we're doing it, we're recognizing which virtual machine those IOs are coming from and the type of I/O. In other words, is this streaming I/O? Is it random I/O? And based on the type of I/O that the application has, we can tune the controller, just what you used to do when you had that single application on a server and the network connected to it. You tune the controller to the application. So our controller auto-tunes to the type of I/O it sees for that application. So this is one way we start to improve the performance of each application as we do it. The second thing, again, based on where we sit, and we build these queues, as I'm talking about, we can let you prioritize the applications, because not all applications are created equal, right? There are mission-critical applications, there are business-critical applications, and there are noisy neighbors who just cause trouble. So we allow you to prioritize the virtual machines or the apps on the physical server so that the ones that are most important get their unfair share of the IOPS that are available, or the bandwidth that's available, so that the most critical applications perform the way you need them to and you don't get complaints from the users. Again, we'll go into it a little more, but very simple to manage. We looked at very complex ways of doing this, and you can do it in very complex ways. We've adopted, the gold, silver, bronze level of doing it, so that if a silver application is not fast enough, make it gold. Very simple in that sense.
Real quick, I just want to clarify. I heard you say it. I want to make sure it's not an agent, it's just a driver.
It is a driver, not an agent. That's correct. Store port mini driver, if I have it right, to be very specific.
Thank you.
And then, because we're software-defined storage, I don't want to confuse things. We actually sell hardware. We have boxes that we sell. We have storage nodes. And the storage nodes are it's a grid. It scales. You start with a minimum of 3 because because we stripe across the nodes, so you can handle the failure of a node. So one of the ways we deal with price performance is these are not expensive, complex boxes. They're single processor boxes. We can handle the failure of a drive, but we can handle the failure of a node as well. And we improve performance because we get a lot of parallel use out of the network. So when we stripe across 3 of these devices, we actually break the write-up into 3 chunks and write in parallel to each of the 3 nodes that are there. So that's why as you scale out, you don't have any single points to send the data through and replicate it around. Everything goes horizontally across, and that's what allows us to continue to scale, get better performance as you scale because you have more bandwidth available, you have more IOPS, you have more CPU, you have more of it, and there isn't a choke point in there that reduces any of that. And we'll talk about what happens with IOPS as we continue to increase nodes, for example, as we go through this.
You're a hardware, you sell hardware, and it integrates with Windows at a driver level. So you're not doing iSCSI NFS, something like one of the more traditional protocols?
That is correct. We are not.
So I understand. So it appears as local storage of the system.
Yes.
But you can't then, could you then, if you wanted to, expose this storage to some like VMware if you wanted to?
So we could run our virtual controller in a Windows virtual machine in VMware, and it would work just fine.
Okay.
So yes, correct. So just wrapping up the high level, because we're going to go into much better detail than I have in these slides, right? We are focused on that Windows Hyper-V market right now. And again, it's all about optimizing the storage, getting the best application performance we can. We do that with the dynamic adjustment and optimization for the type of I/O coming from each of the applications. We do that by having the quality of service. Again, because we own both ends of that wire, not only from the protocol point of view, but we know what storage is out there, we know what's available, and we can control, from the server side as well as from the storage side to deliver that quality of service. We have the scalability. You put in 3 nodes to get started. You can add nodes one by one or add them n at a time. It can either just start using those nodes for additional capacity, or it can rebalance across new nodes that you put in. Will work both ways. Right now we have a limitation of 250 nodes in a pool. So that's, that's 3 petabytes roughly. And it's easy to manage, right? Not only is it easy to install, but the management, right, doesn't change any scripts you have because it looks like a local SAS drive. It fits into all of the Windows tools for managing because it looks like local storage. Matter of fact, it even, if you go as far as storage spaces, which only take JBOD, it will fit inside of storage spaces and give you a better solution than JBOD if you want to use storage spaces. So fits very nicely into that overall ecosystem.